Okay, in this video, we're going to talk about sampling error. We've talked at the beginning of the semester about the difference between samples and populations and correspondingly a statistic or a parameter. We've talked a little bit about that kind of stuff and built up some ideas of how we might construct a random sample and what they're useful for. But then we deviated off to probability. What we're going to do now is try and merge the two things together. So we're going to start by taking a look at an example where we can compare x bar and mu, the sample mean and the population mean. We've got a statistic here and a parameter. From there, we're going to define sampling error, and then we're going to investigate what might happen when we sample from a population over and over again, and finally tie this all up by thinking about a sample statistic as a random variable. So that's where we're going to be at. Let's take a look at this first motivating example. This is a real basic, boring example, but let's say we've got a small population of 10 different classes, and these are the enrollment numbers for those 10 classes. 29, 26, 24, 24, 25, 25, 23, 25, 24, 29, whatever. We can go ahead and calculate a population mean. I've already done it for us. Hopefully this is right. This 25.4, and we could go ahead and interpret this. But what we want to do is randomly select only 5 of these 10 classes and try and construct a sample mean from here. Now we know, hopefully, x bar will reflect mu. We hope that they're going to be connected to each other, right? The average of a sample should be connected to the average of a population. But let's take a look a little bit more deeply at it. So what I've got is some code off on the side where I'm going to just randomly sample 5 different times, and I'll write down the samples as we go, and I'm not going to actually calculate these by hand, but I've got the sample means calculated. So from this population that we had above here, let's go ahead and sample 5 different samples. So our first one is 25, 24, 29, 29, and 26. And if you average those things up, you get 26.6. And our next one, if we do this again, we might get 23, 29, 25, 24, and 24. And the sample mean here is 25. And we could do this again. And we could say our third sample might be 24, 25, 25, 23, 26. And the sample mean there is 24.6. And we could do this again. Our fourth sample might be 24, 24, 29, 26, and 25, and the sample mean here is 25.6, and our last sample that we take could be 29, 23, 25, 24, and 24, and our sample mean there is 25. Cool. Hopefully I've copied all this stuff down correctly from the screen off on my side, but these are actually 5 random samples of size 5 from that population here, where again our population average was 25.4, and clearly our sample averages are a little bit different from there. So what we want to do is just think about what is going on here. One of the questions that we might ask is, well, what happens if you average out all of these different means that we have? What might that be? And I can calculate that off on the side here really quick. It looks like our average of these things, the average sample mean, is 25.36. So we might think about this and say, well, wait a second, that average is awfully close to 25.4, right? And we've only done 5 samples. What happens if we keep doing this over and over again? Before we get to there, I want to talk briefly about sampling error. Sampling error is just this difference that we have, and here are the sampling errors that we have for these 5 different samples. And what we might notice is that if you average these out, the average is close to 0. And hopefully that's kind of an intuitive thing, that as we construct these samples over and over and over again, they are on average going to look like the population if we really are randomly selecting things. That's the whole point of a random sample, is that they reflect what the population is doing. And obviously, again, if we are just selecting randomly, it might not be a picture-perfect representation of the population, but if we repeat that process over and over again, then in the long run, the samples will look like the population. So that's what we've got here, that this sampling error here is just the difference between our sample mean in this case and the population mean. And these are all small numbers. And if we repeated this over and over, we would imagine that the average would be 0. Okay, so again, what happens if we sample from the population over and over again? Well, we get this sampling error going to, on average, 0. And we could say that the sample means might not always match the population mean, but the average of the sample means would. So there's what we go. Our average sampling error, we might say the average sampling error is 0. The average population mean, we might say something like the average population mean would be, the average sample mean would be mu, the population mean. All this leads us to this idea that a sample statistic can be thought of as a random variable. So let's just look at our definition of random variables. It's a variable that takes on different values, different numbers, based on some underlying random process or experiment. And so in this case, the random process or experiment is just the construction of our samples. Once we do that, our sample is a whole bunch of values that are put in there randomly. And so anything calculated from those values is a random variable. So any sample mean is a random variable, and really any sample statistic is a random variable, which is great, I guess, cool, but who cares, right? Why is this important to us? Why does this matter? Well, what we've done with random variables so far is looked at their probability distributions. And so if random variables have a probability distribution, then what that means is that these sample statistics have probability distributions as well. So that means that if we go back and think about all of these sample means that we built, we can put all these together and get some kind of theoretical probability distribution that they're following, that we're really selecting from. And if we have a distribution of these sample means, then we can start thinking about the overall structure of those sample means, or really any sample statistic. So the next part of our course is all based around this idea of thinking about sample statistics and trying to figure out what the distributions of these sample statistics are and what they might tell us about the population parameter that we're kind of estimating or thinking about here. So that's where we're at. That's where we're heading towards.